sampling error is a really important concept. So we're going to do an example, and you'll see in just a minute why I needed to record this rather than just talking about it in class. So again, sampling error is the variation from sample to sample within the same population. So today we're going to look at the population, a small population of the turtles in my pond. And we're going to look at how much they weigh and see what that average is. So by collecting a sample, the goal would be to collect our sample, get the mean and standard deviation of their weight, and then hopefully be able to say, okay, the sample is this average, this mean weight, and this standard deviation. I think that applies to the entire pond, and I can safely estimate that on average, my pond has a mean weight of this. So that's what inferential statistics allows us to do. So this is why you need to understand sampling error. It's a very important concept. So I have 15 turtles in my pond. So I'm going to take some relatively small samples. I'm going to take 3 samples with 3 turtles each time. And I'm going to go ahead and go over to a different video.
All right, so I have successfully caught 1 turtle. You can hear more turtles wandering around. Oh no, we have an escaped turtle. So Spike has also escaped. I'm gonna have to go run and catch him. But for right now, we have Fiona. I'm gonna put her on this scale. So Fiona weighs 2.5 pounds, and you can see that she is now going to bail. She did not enjoy that. Women don't like talking about their weight. You're not going to go in the pond. Now you're going to sit there. All right. So Fiona of 2.5 pounds, and now we need to go and get Spike back because he escaped his enclosure. So Spike is our second turtle that we captured today. Spike, how much do you weigh? You weigh 1 pound and 1/8 ounce. So Spike is actually pretty friendly. Say hi, Spike. No, you don't want to be petted today? Okay. So we're going to release Spike. Oh, you're just not going to run? Me being camera shy? Well, Spike's going to go back in the pond. We'll see if he decides to leave. And our final unwilling participant is Wolverine. So Wolverine here, let's see how much you weigh. Wolverine weighs 1 pound, 12 ounces. Oh, and there goes Spike into the pond. And in. All right, Wolverine, do the last of this sample. I'll put you in here. So now we have 3 turtles and we have their weights.
So what you didn't see is that before that, I had collected 2 other samples, and I also weighed the rest of the turtles. So I've created a spreadsheet here, and you can see that we now have 3 samples. So the first sample is the one that I showed you. We have Fiona, we have her weight. So I took the weight in pounds and I multiplied it by 16 to get 16 ounces. So we have Spike, Wolverine here. The mean for our first sample was 28.8 ounces. And the mean for our standard deviation for our first sample was 11.2. Now this is kind of interesting. Our mean is 28.8 and Wolverine is our median value. It's the middle value. It's the same as the mean. So pretty unusual. All right, so now sample 2, we had Gigantica, Fiona, and Kenny. And you can see that this is just a bigger group of turtles. And so this sample has a 36.8 mean and a 13.1 standard deviation. Sample 3 is smaller. So Spike, Groot, and Kenny are all smaller turtles. And so we have a smaller mean and a smaller standard deviation. Now, all of these samples vary, right? So this is the sampling error that we're talking about, is the difference in these samples, because we're sampling from the same population. Some of the turtles showed up twice. So Fiona is pretty nosy. She likes to know what's happening around the pond. So she is floating right at the surface so I could catch her easily. Spike is friendly, so he showed up twice. So you have to think about, why might people be represented in a sample? Is there something different about them that could affect your results? But overall, your samples are going to vary. That's normal. So sampling error isn't an error as much as it is just a difference that naturally occurs. So the mean of all the samples, if I were to actually look at the mean of this sample, and that sample, the average of those three means is 29.48. So it's a little bit more moderate overall average. Now, I happen to have my turtle pond population and weight, and you can see that it ranges from Gigantica, who's the heaviest at 48 ounces, all the way down to Spike, who is the smallest at 17.6 ounces. And I have here the pond parameters. So it's unusual to have population parameters. We usually have to infer them. We have to guess at what they might be. And that's why we collect samples. So I wanted to show you what it might look like to have real samples when we know the parameter. So here our mean is 31.99. So this is our actual average. So if I were to conduct a study and I looked at this average at 29.48 and I said, okay, the sample, I think it represents the population, I would be guessing that the mean is about 29.48, which is not that different, right? So we got pretty close. But what if I were to draw this small sample and I said, oh, this sample, I must have about an average weight of 23 ounces in my actual pond. So we want to have big samples because it's going to get us better information. So the bigger your sample, the closer you are to estimating your parameters. So just to note here, I calculated the mean for all of the turtles here. So that's what that is. I also calculated the standard deviation, which is about 10 ounces. The median is 28.8 and the mode is 28.8. So our middle value here is the median. And then the mode, you can see here from this frequency table I put together, 2 turtles weigh 28.8. So that's 2 times that shows up. All the other weights are just 1 time per turtle. So that concludes our sampling error demonstration for today.